Welcome, star fans. Have you ever imagined witnessing a galactic event so fantastic that it creates shadows across Earth? This extraordinary phenomenon may be closer than we think. In the Orion constellation, the star Betelgeuse is exhibiting strange behavior, indicating an impending cosmic event that could illuminate our sky like never before. But when exactly will Betelgeuse explode? And what will this celestial spectacle look like? According to scientists, this explosion could reveal deep cosmic secrets. Join us as we explore the mysteries surrounding Betelgeuse and the potential effects this event may have on Earth and the entire solar system. The importance of Betelgeuse. Located approximately 650 light-years away in the Orion constellation, Betelgeuse is no ordinary star. It is a red supergiant, one of the most luminous stars we know, shining over 100,000 times brighter than our Sun. But why is this massive star so significant? Beyond its brilliance, Betelgeuse holds deep cultural importance. The name Betelgeuse comes from the Arabic phrase Yad al-Jawza, meaning the hand of Orion. This star has been observed and recorded by ancient civilizations for centuries, guiding travelers and captivating astronomers with its distinct red hue, setting it apart from other stars in the constellation. Imagine a single star so enormous that it could overshadow our entire solar system. To put this into perspective, if Betelgeuse replaced our Sun, its outer edges would extend all the way to Jupiter. But how does such a star achieve these titanic proportions? At around 10 million years old, Betelgeuse is much younger than our 5-billion-year-old Sunday. However, its massive size forces it to consume fuel at a much faster rate, leading to a significantly shorter lifespan compared to other stars. This celestial giant, possessing a volume large enough to hold over 1 billion suns, is nearing the end of its life cycle. The final stages of Betelgeuse. When stars of this size reach their twilight years, they don't simply fade away. They explode in a supernova, a powerful event of unimaginable energy and brightness. Such an explosion can outshine entire galaxies, casting shadows of light across vast cosmic distances. The last time Earth witnessed a nearby supernova was in 1604, before the invention of modern telescopes. The Kepler supernova, visible for over 18 months, was the most recent supernova observed in the Milky Way. It was so bright that it rivaled other stars in the night sky and even remained visible during the daytime for several weeks. Ancient records and scientific insights. Ancient records from civilizations, including those of Chinese and European astronomers, documented the appearance of new stars, providing insight into the violent deaths of massive stars. The remnants of these explosions, now observed as expanding clouds of debris, continue to provide valuable data about the destructive end of supergiant stars. Although supernovae are rare for Earthbound observers, imagine an event so powerful that it rivals the brightness of the full moon, casting shadows on Earth at night and possibly being visible in daylight. The radiation emitted by such an event would be so intense that it could ionize our atmosphere, potentially disrupting satellite communications and even affecting our climate. Betelgeuse, with its unpredictable dimming patterns, appears to be preparing for such a dramatic event. Could we be on the verge of witnessing one of the most extraordinary occurrences in the universe? The Great Dimming of Betelgeuse. Between October 2019 and mid-2023, Betelgeuse underwent a remarkable transformation that captured the attention of astronomers and stargazers alike. Known as the Great Dimming, this change in the star's brightness, which had been relatively stable for decades, suddenly decreased drastically. The dimming was so pronounced that even casual observers could notice the change when comparing Betelgeuse with other stars in the Orion constellation. This suggests that we may not be centuries away from seeing Betelgeuse's supernova. It could happen within the next few decades, or perhaps even sooner. By April 2023, astronomical observations confirmed that Betelgeuse had returned to its normal brightness levels, leading many to believe that the dimming period had ended. However, in a stunning twist, over the following months, Betelgeuse's luminosity surged by an unexpected 50%. While brightness fluctuations are normal for variable stars, such extreme changes in luminosity are highly unusual for a star like Betelgeuse, which typically follows predictable cycles. This unexpected increase in brightness reignited interest in Betelgeuse, raising questions about what caused this sudden shift. Why did this once predictable star suddenly undergo such dramatic changes? Theories behind Betelgeuse's behavior. Stars are not just fixed points of light in the night sky. They are dynamic, evolving entities with life cycles, behaviors, and mysteries of their own. For most of its existence, Betelgeuse maintained a relatively stable 400-day brightness cycle. However, with the Great Dimming, it appeared to defy this established pattern, challenging our understanding of stellar phenomena. You might be wondering, are we on the brink of a cosmic revelation? While the exact reasons behind Betelgeuse's irregular behavior remain under investigation, an intriguing theory has emerged. This hypothesis involves stellar activity and mass ejection, presenting a fascinating scenario. Imagine Betelgeuse as a gigantic volcano, quietly expelling vast amounts of material into space. Observations from the Hubble Space Telescope revealed that Betelgeuse ejected a massive amount of material from its surface into the cosmos. This eruption, an extraordinary event, involved around 400 billion times the mass typically ejected by solar phenomena, equivalent to several times the mass of our Moon. Such events can lead to the formation of a dense dust cloud around the star, temporarily reducing its apparent brightness and making it harder to see. As this dust cloud dissipates or is pushed away by the star's radiation pressure, the star's true brightness is revealed once again. This could explain why Betelgeuse returned to its normal luminosity after the dimming period. Is Betelgeuse nearing its end? These recent developments suggest that Betelgeuse is far from done surprising us. Many astronomers speculate that it is approaching the end of its life. But what exactly is a supernova? A supernova is a cataclysmic explosion of a star that can outshine an entire galaxy. This event occurs when a star undergoes a sudden core collapse, triggered either by the accumulation of mass from a neighboring star or, in Betelgeuse's case, the depletion of its nuclear fuel. As this fuel runs out, the star's core collapses inward, setting the stage for a catastrophic explosion. But what ultimately drives a massive star like Betelgeuse toward its final fate? Born from the gravitational collapse of gas and dust in nebulae, stars like Betelgeuse begin their lives by fusing hydrogen in their cores. This initial phase, known as stellar fusion, fuels the star's energy and light, until the inevitable end arrives. As the principal succession goes on for billions of years and structures the underpinning of a star's life cycle, hydrogen reserves are depleted, and the star advances to new stages, starting with a combination of helium. For Betelgeuse's situation, this change brings about the development of heavier elements like carbon and oxygen. In the end, as the helium reserves are exhausted, the star expands into a red giant. Over the long haul, as the star's mass increases, it enters phases of even heavier fusion, each step marked by the creation of progressively complex elements. At last, when iron forms at the core, it can no longer produce the energy needed to counteract the force of gravity, leading to a collapse and ultimately a massive explosion, the supernova. Betelgeuse's coming explosive end has been the subject of much scientific inquiry. Recent research from Japan's Tohoku University suggests that the star may already be in its carbon-burning stage, with its core potentially collapsing within the next few years. However, not all experts agree. Studies from Hungary's Konkoly Observatory propose that Betelgeuse is still in the earlier helium-burning stage. Despite these differing conclusions, one thing is certain: Betelgeuse is destined to become the next supernova in our Milky Way. But when will this happen? The timing remains an ongoing mystery, with estimates ranging from just a few decades to as far as 100,000 years into the future. While scientists debate the exact timing of Betelgeuse's end, one undeniable reality remains. When it happens, it will be a truly spectacular event. As we contemplate the potential for such a cosmic explosion, it is essential to consider its broader implications for our galactic neighborhood. When Betelgeuse reaches the end of its life, the shock waves produced by its supernova will impact the surrounding interstellar medium. These shock waves will create vast regions of ionized gas, enriching space with heavier elements formed during the star's lifetime. This process plays a fundamental role in the ongoing cycle of star formation and planetary creation. Additionally, the light from Betelgeuse's eventual explosion could serve as a natural laboratory for astronomers studying the life and death of massive stars. By examining the light curve and spectral features of the explosion, scientists can gain valuable insights into the physical processes occurring during such catastrophic events, refining their models of stellar evolution. Beyond its scientific impact, a supernova could have profound cultural and social consequences. Throughout history, celestial events have inspired artists, writers, and philosophers to reflect on our place in the universe. Betelgeuse's potential explosion could spark a new wave of creative expression, as people across the globe look up at the night sky, contemplating the fleeting nature of existence and the vastness of the cosmos. Practically speaking, radiation from a nearby supernova could significantly impact our technology. Increased radiation levels could disrupt satellite communications and navigation systems, prompting the development of new technologies to protect and safeguard us from such effects. Ultimately, whether we view Betelgeuse's explosion through a scientific lens or from a more philosophical perspective, it serves as a reminder of the impermanence of existence. Even the most massive stars eventually reach their end, and their ultimate fate mirrors our own fleeting but profound moments in the grand expanse of time. As we continue to ponder the possible supernova of Betelgeuse, it is crucial to consider how such a massive stellar explosion could influence the broader cosmic landscape. The event would not only affect our immediate region in the Milky Way but could also have far-reaching effects on the interstellar medium in significant ways. The shock waves from Betelgeuse's supernova would generate vast regions of ionized gas, creating areas of intense radiation and cosmic activity. This ionized gas would enrich the surrounding space with heavier elements, many of which are crucial for the formation of new stars and planets. This enrichment is a vital part of the cosmic cycle of matter. Stars like Betelgeuse create and distribute elements such as carbon, oxygen, and even heavier elements that play a fundamental role in the formation of new stars, planets, and even life itself. In this way, the life and death of massive stars contribute to the very fabric of the universe, fostering the next generation of celestial bodies. The potential explosion of Betelgeuse could mark the beginning of a new era of star formation in the Orion constellation and beyond. From a scientific standpoint, the light and radiation from a supernova provide astronomers with an incredible opportunity to study the final stages of stellar life. The light curve, the pattern of how a star's brightness changes over time during a supernova, can provide astronomers with crucial data about the star's mass, age, and internal composition. The spectral features of the explosion, which can be broken down into different wavelengths of light, offer further insight into the elements present in the star and the forces driving its explosive death. By analyzing these factors, scientists can refine their models of stellar evolution, improving our understanding of how stars live and die. Supernovae like Betelgeuse's could ultimately help us understand the fundamental processes at play in the universe's most extreme phenomena. Beyond immediate scientific advancements, a cosmic explosion of this magnitude would likely have significant cultural ramifications. Throughout human history, the stars have been a source of inspiration and wonder. Witnessing a supernova would undoubtedly captivate people across the world, sparking reflection on humanity's place in the cosmos. The awe that a supernova generates could fuel a renewed interest in astronomy, much like the Renaissance era, when scientists and philosophers began reshaping our understanding of the universe. During that time, the skies were no longer just a backdrop to human life, but a place of profound mystery and potential discovery. Similarly, the appearance of Betelgeuse's supernova could spark a new wave of creativity. Artists, writers, and thinkers would undoubtedly draw inspiration from this celestial event, producing works that explore the transient nature of existence and the vastness of the universe. Literature, music, and visual art could all be influenced by the idea of a massive star reaching the end of its life, just as the supernova of 1604 inspired masterpieces and philosophical thought. On a more practical level, radiation from a nearby supernova could pose significant challenges for human technology. As the explosion releases vast amounts of energy, it could potentially interfere with satellite communications and other space-based technology. Increased radiation might impact Earth's atmosphere, with potential effects on GPS systems, telecommunications, and other technological systems that rely on satellites. These challenges would necessitate the development of new protective technologies and innovations, further driving advancements in space exploration and satellite technology. As a result, space agencies and experts would need to work on enhancing our protective capabilities to safeguard Earth from the effects of such intense radiation. This could involve the creation of new materials, protective satellites, or even strategies for mitigating the risks posed by cosmic radiation. As our reliance on technology continues to grow, addressing these challenges becomes increasingly crucial for ensuring the safety and security of satellite systems and infrastructure. On a deeper level, the impending explosion of Betelgeuse serves as a reminder of the transient nature of the universe. It emphasizes that even the most massive and seemingly indestructible stars are not eternal. Betelgeuse's inevitable fate highlights the cyclical nature of the cosmos. Stars are born, they live, and they die, creating and destroying in the process. This awareness of the impermanence of celestial bodies can lead to greater philosophical insights into the nature of time and existence. How does our brief existence as humans compare to the millions or even billions of years that stars like Betelgeuse live? What does it mean to be part of a universe that is constantly changing, where nothing is permanent? As we gaze at Betelgeuse, whether through a telescope or simply with our eyes, we are reminded that the universe is in constant flux, and so are we. We can find inspiration in the life cycle of stars, and perhaps, just as Betelgeuse inspires us today, it will continue to fuel the imaginations of future generations as they ponder the mysteries of the universe. Looking ahead, one thing is certain. The supernova of Betelgeuse will be a cosmic event of extraordinary scale, one that will leave a lasting mark on our collective imagination. Whether it happens in our lifetime or in the distant future, Betelgeuse's eventual explosion is an inevitable event that will continue to captivate astronomers, scientists, and dreamers alike. In the grand scheme of the universe, the death of a star may seem insignificant, but to us, it is a reminder of the grandeur and impermanence of existence, a humbling thought that calls us to appreciate the beauty of the cosmos and our fleeting place within it.